Welcome to today's deep dive. We've got a really fascinating stack of sources for you today.
Yeah, it's a pretty dense mix. We're looking at academic white papers and a highly confidential pitch deck from 206 Innovation.
Right, and also some advanced briefing notes for the upcoming NVIDIA conference. So our mission today is to explore their incredibly ambitious curvature variable physics platform.
Or CVP for short.
Exactly. Okay, let's unpack this. Because the stakes here are, well, they're massive. In our current landscape of 2026, standard enterprise monitoring tools are, well, they're basically stuck in the past.
They really are. They just check if a system is running.
Right, like looking at network uptime or, data throughput. But they completely ignore the integrity of how an AI is actually making its algorithmic decisions.
And that massive blind spot is exactly what creates the core problem we're facing today. The sources actually refer to it as the entropy wall.
The entropy wall.
Yeah, so as organizations aggressively scale up large language models and autonomous agents to run complex workflows, these systems suffer from a mathematical phenomenon known as entropic drift.
Right, which sounds incredibly sci-fi, but what does that actually mean in practice for you?
Well, think of entropic drift like a digital game of telephone played at the speed of light.
Oh, wow.
Yeah. As these AI models run continuously without a physical anchor to reality, their logic gets slightly distorted over time.
So when they're forced to reason outside their initial training data, they don't reduce uncertainty.
Exactly. They actually amplify chaos. It snowballs until the AI becomes a highly unpredictable enterprise liability.
Here's where it gets really interesting. The solution created by 206 Innovations founder Timothy J. Dillon sounds like magic, but it's pure mathematics.
It is. The CVP platform uses something called the Dillon operator.
Right, which relies on the mind-bending concept that the speed of light is actually sensitive to curvature.
Represented in the math as C equals C of R. By applying these physics, they are effectively anchoring digital data streams directly to physical laws.
So they're taking inherently unpredictable, probabilistic AI and forcing it to become completely deterministic.
What's fascinating here is how they operationalize that dense math for actual enterprise use through a component called the proof bundle exporter.
Wait, let me make sure I'm getting this. When an AI makes a complex or unexpected decision, this exporter creates a cryptographically secure replay of the exact computational pathway.
Yes, it's essentially a flight data recorder, but for AI reasoning.
That is the perfect analogy.
Yeah.
So standard observability logs might tell you what happened, but this proof bundle shows you exactly why it happened.
Exactly. It traces the exact sequence of algorithmic logic. This solves what industry analysts have been calling AI's missing primitive.
Okay, I have to ask about something specific from the pitch deck. Because when I read the notes on Operation Geodesic Anchor, my jaw actually dropped.
I know.
Are they really using a volcano to do this?
They absolutely are. To literally ground these computational models in physical reality, Innovation placed a highly sensitive refractance sensor array in a 2-kilometer deep borehole right in the middle of Yellowstone National Park.
That is wild.
It's incredible engineering. They are literally using the magmatic flux of a supervolcano to physically anchor the AI's reasoning.
And they're debuting this live, linking the Yellowstone array directly to an NVIDIA H100 cluster at the NVIDIA GTC 2026 conference.
They are.
So the math is airtight and the engineering is spectacular. But how does this translate to everyday stakes?
If we connect this to the bigger picture, the commercial strategy is just as aggressive as the tech. This core deterministic software engine is infinitely reusable.
Once that central logic is built, they can apply it to diverse industries using modular domain packs.
Right, like deploying this to secure 6G telecommunications and industrial power grids.
They even launched a safe bet overlay to stop algorithmic fraud in high-frequency sports micro-wagering, right?
Yes. And because they aren't just doing this for the sake of science, they are projecting massive numbers. We're talking about an estimated $461.6 million in revenue by 2030.
Wow.
And because it's a reusable software platform, they are boasting 43.7% EBITDA margins.
And they're minimizing their execution risk by fueling all of this development through strictly milestone-gated capital raises.
Exactly.
So what does this all mean? It means that as autonomous agents inevitably take over your daily enterprise workflows and manage complex global networks, simply hoping they make the right choices isn't a valid strategy anymore.
Proving the exact mathematically sound logic behind your decisions is now a mandatory billion-dollar necessity.
It really is.
This raises an important question. If we are physically tying our most advanced digital minds to the raw geographic heartbeat of the planet, what happens when the planet itself changes?
Wow.
If a seismic event shifts that Yellowstone borehole even slightly, does our infallible AI logic suddenly shift with it?